Alrighty, here are a few things that are going to be useful for this. So when we've got a binomial raised to a power, we can just go through and FOIL and then FOIL with the binomial and a trinomial and then FOIL with a binomial and a four-numbered polynomial and just continue on until we do that 9 times. Except for that sounds like it would suck. So we are not going to do that. And instead, we are going to use Pascal's triangle, which I have written out right here, to the 9th power. So this bottom one is the 9th power, and that's the one that we'll use. I also have just written i's raised to different powers because that's going to be helpful for us as well. I is a cyclical thing, so once we get to I to the 5th, all it is just I again. And so I've kind of written them down here so that we can see as i's raised to a specific power, we can see what happens with that I. Sometimes it's positive 1, sometimes it's negative 1, sometimes it's negative I. So we're just going to go through and plug all these values in, and I'll show you how to use Pascal's triangle in just a second, but we're going to plug all these values in and then multiply and simplify as we can and move on from there. So as we're using Pascal's triangle, these are all just going to be multipliers of our coefficients. So basically we take the first term and that's what we're going to use first, and then we'll take the second term and that's what we're going to use second, and I'll show you kind of how to insert those into Pascal's triangle. But what I'm going to do is I'm just going to take all of these coefficients down here and space them out so that I will have space between each one. And so I'm just going to add them all together, and then I'll determine signs really later because of this negative right here. Signs are going to fluctuate pretty regularly. So the first part is just putting all these numbers down: 1, 9, 36, 84, and I'll probably need a couple of lines here. 126, that's not enough space. 126, and I do 126 twice, and then I have 84, so I'm just going to bring it down here, 84, 36, 9, and 1. So now the way that we do this is we just take this first term, and this is the way I actually like to do this, is I just put that first term everywhere. So I'm just going to do 1, and I'll add exponents here in just a minute. So these are just all 1s. 1, 1, all the way through. And then I'm actually going to do the same thing with the second term, and I'm going to preserve the sign with it as well. So I'm going to have in parentheses negative root 3i, and then negative root 3i, and I'm just going to keep doing this all the way throughout. Okay, whew, there we go. Now comes the part where we're actually going to use these exponents here, okay? So the way that this one works now is we start at 9 for our first term, and we just count down on the first term. So I'm going to do 1 to the 9th, then 1 to the 8th, 1 to the 7th, 1 to the 6th, 1 to the 5th, 4th, 3rd, 2nd, 1st, and finally 1 to the 0, okay? Which, as you'll notice, 1 to any power is just going to be 1. So those are going to be relatively irrelevant. But then when it comes to this negative square root of 3i, we're going to go starting from 0 and count up to 9. Okay, so now this first one is going to be to the 0 power. The second one's going to be to the first power, to the second, to the third, to the fourth, to the 5th, 6th, 7th, 8th, and 9th power. So this is the benefit of using, let me differentiate that a little bit. This is the benefit of using Pascal's triangle, is that now we can just kind of plug all these values in, and now we can just do the calculating as we go here. So that first term, let's just simplify this first term. Anything to the 0 power is just going to be 1, okay? 1 to the 9th power is just 1, and 1 is just 1. So this first one is just going to be 1. Now you'll also notice here we don't have any variables, so generally when we're using Pascal's triangle we have a variable, but instead we're only going to be working with our I values, okay? So we won't have variables, so at the end we'll actually be able to do some simplification, and we really should end this whole thing with a binomial, since we're only going to be dealing with positive i's, negative i's, or positive and negative ones. So now let's look at this next term. Now we've got 1 to the 8th. So again, we can just ignore all of these 1 exponents because they're just going to be 1. The important thing, it's going to dictate sign. It's also going to dictate some other values, is this negative root 3i. So we're just going to, right now I see that negative root 3i is raised to the first power, which means it's going to be negative, okay? And it's just going to be negative root 3i, and that's all. But this is all times 9, right? So I'm going to have minus 9 root 3i. There's my second term. So I'm going to check these off as I go. This next one is 36. I'm going to look at the sign again, and this one is going to be negative, but squared, so with an even exponent, that's going to become a positive. So I'll have plus 36, and then I'm actually not going to simplify any further than just signs right now. I'm going to just leave it as root 3 squared and I squared. Okay, I'm not going to simplify any other signs just yet. I'll deal with that in the next step. Then I've got, so done there. Now I've got 84. Again, I see that negative sign with this odd power, so it's going to be a negative. I'm going to subtract 84 root 3 I, and this is root 3 cubed, and this is I cubed. Okay, and then the next one is 126. And I see an even power with this negative, so it's going to be plus 126 root 3 raised to the 4th power, I raised to the 4th power. All right, so I'm done with that. Oop, got to check everything off. And then I have another 126, which is negative with an odd power, so it will be minus again. So it's minus 126 root 3 to the 5th power, I to the 5th power. Okay, so we're squared away there. Then I've got 84 again with negative with an even power. So it's plus 84 root 3 to the 6th power, I to the 6th power. All right, done there. 36 with an odd power, so we're going to be negative. So minus 36 root 3 to the 7th, I to the 7th. Then 9 with an even power right here, so we're going to be positive, so it'll be plus 9 root 3 to the 8th power, I to the 8th power. And finally, we have one more odd, so it's going to be negative 1 root 3 to the 9th power, I to the 9th power. Okay, so now that I've gotten that step done, check that one off as well. Now I'm going to start looking at the next thing I want to deal with is these i's, because i's are all just going to be I, negative 1, or positive 1. So let me just simplify those first, and then we'll start dealing with these root 3's. So that first I is just going to be an I, right? So it'll be 1 minus 9 root 3i. Okay, so check that off as I go just to keep these things in order. Now I've got an I squared. I squared I know is negative 1, so positive 36 root 3 squared. I squared becomes negative 36 root 3 squared. Okay, and I'll deal with this in a little bit. Now I've got the I cubed, which I cubed is actually negative I, so now I've got negative 84 with a negative I, so I've got positive 84 root 3 cubed I, okay, and then I to the 4th, that's positive 1, so I've got positive 126. Oh, I'm not crossing things off, I'm bad at that. Positive 126 root 3 to the 4th, okay, check that one off. Now I've got negative 126 I to the fifth, and this is where this kind of writing out comes in handy. I to the fifth is just I, so I'm going to have negative 126 root 3 to the fifth I. And the next one, 84, I to the sixth is actually negative 1, so it was a positive 84. Now it's going to be negative 84 root 3 to the sixth. And the I is gone, right? So no I there. Then I've got negative 36. I to the seventh is negative I, so it'll be positive 36 root 3 to the seventh I. Crossing these things out again. And then 9 root 3 to the eighth. I to the eighth is just 1, so it's going to be plus 9 root 3 to the eighth. And finally, this last one, I to the ninth is just I, so it's going to stay negative root 3 to the ninth I. Okay, so now we've simplified some i's. Now let's look at some of these radicals. So all radicals, I'm actually going to just think about them as fractions, right? So a square root is the same thing as, like if I took the square root of x, it would be the same thing as x to the 1/2 power. Okay, so the square root of x squared would be x to the 2/2 power. So I'm just going to make these into fractions and kind of reduce them. Okay, so I have 1 minus 9 root 3 I minus 36 times, let's see, that would just be 3, right? Then I've got plus 84 times root 3 to the 1 1/2. So I'm going to actually look at this as though it was 3 and the square root of 3. Okay, so oops, let me check these all off. So check, 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 check. And then, so I just made this 3/2. Here's what I did so that you can see it as we go forward. Root 3, oops, not root 3, but 3 to the 3/2. Separated it out like this, 3 to the 2/2 times 3 to the 1/2. This is just 3, because that cancels. So I've got 3 times the square root of 3, so that's what I put in right here. Then I've got plus 126, and the root 3 to the fourth, which it would be just 3 to the 4/2, which is the same as 3 squared. So canceling that out, minus 126, and then I've got 3 squared again, times 3 to the square root of 3, the square root of 3. There, oh, and this one has an I, can't forget the I. And then the next line here, I've got minus 84 3 to the root 3 to the 6th, that is the same as root 3, that is the same as 3 cubed. So it's minus 84 times 3 cubed, Jiminy Christmas, plus 36, 3 cubed times the square root of 3. So in a minute here, we're going to have a lot of simplifying to do. I plus 9 root 3 to the 8th is just 3 to the 4th, minus root 3 to the 9th, which is just 3 to the 4th, times the square root of 3. Okay, so now all that's left is just simplifying. So I'm going to leave everything that's radicalized and just leave it there for now and do just the multiplications. So it's 1 minus 9 root 3 I minus 36 times 3, which is 108. I'm going to check these off as I go too. Plus 84 times 3, which is 252 root 3, so plus 252 root 3. Then I have 126 times 3 squared, so 126 times 9, plus 1,134. There we go. Minus 126 times 9. So minus 1,134 root 3 I. Then minus 84 times 27, which is minus 2,268. Check that one off. Then 36 times 3 cubed is 972, so plus 972, root 3I. Check that one off. Plus 9 times root 3 to the 4th, so 81 times 9, plus 729. And last one, 81 minus 81, root 3I. Whew! What a whirlwind. All right, so now we've got several different kinds of common terms or like terms. I have just whole numbers, and I have root 3's, and I have root 3i's. So let's take whole numbers first. I'll circle all of them. There are all my whole numbers. Add those all together. 1 minus 108 plus 1134 minus 2268 plus 729. That should equal negative 512. All right. Hopefully that's an option on your answers. We'll see. And then I'll take all of the, let's do just the root 3's next. So I've got root 3. Oh, that's a root 3i. Oh, it's just that one that's a root 3. So the rest are root 3i's. Did I do that right? Let's see. I did not. This should have an I on it right up here. That should have an I on it, which means that should go to be an I as well. So now I only have two types of like terms, which is kind of handy, so we will do all of those now. Root 3i's. So go ahead and add those together, so that is negative 9 plus 252 minus 1134 plus 972 minus 81. Ooh, that cancels out. They all cancel out, so it's plus 0 root 3i. Huh. I don't think that's an option in your answer sheet, because the answer should just be negative 512, according to what I just did. I'm going to look at Wolfram Alpha and see what it says too. Well, just double check my work, and this is correct. However, that is not an option for your answers on the actual question, but this is the right answer. So I would say email your teacher. All right, well, there you have it.